Hey everyone, what's up? It is Nick here. I wanted to lend a little bit of inside intuition. I'm going to simplify the nephron kidneys to a very simple, easy to understand concept. So first we'll go over is the nephron. So for, something that he didn't go over first, which I think is easier to understand the whole concept, is what the nephron is. So they're microscopic filtering units of the kidney, blah, blah, blah. What are the pieces of it? So first piece we have is the glomerulus, which is this ball here of capillaries. We have two parts of that. We have the one artery going in. It's a tiny artery, so it's called an arteriole. The one going in is the afferent arteriole, so it's called the afferent arteriole going in. The one leaving is called efferent. Think of E as exit and then A as the first letter of the alphabet, so it's starting it. The next part you're going to have is the actual capsule, and that's called Bowman's capsule, the nephron capsule, renal capsule, bunch of things. That's the actual capsule. And then you're going to get to the actual nephron tube or tubule. So the first part you're going to have is the proximal convoluted tubule, or the PCT. And then you're going to go downward, and that's going to go to the nephron loop, or the loop of Henle. And that's going to go back up towards the distal convoluted tubule, which goes then to the collecting duct, which then the collecting duct goes down through the kidney, dumps into the renal hilus, which then dumps into the ureters. So a couple things you also need to know about this part is there's two parts of this. So if you remember the kidney, you have your cortex, and then you have the medulla. The top part where you have the proximal convoluted tubule, the distal convoluted tubule, and then the top of the collecting duct, that's in the cortex. And the bottom part is more in the medulla, which is the middle part of the organ. Not to be confused with the medulla oblongata of the brain. They just say medulla for a lot of stuff. This is the medulla of the kidney. So, importance of that, the renal cortex is high in potassium, has a higher potassium content, and then the renal medulla is very, very high in salt content. All right, so that allows us to maintain our salt or potassium-sodium balance. So when the blood comes in, well, that's what we'll go over next. So the next piece I wrote here was just a easy way to conceptualize the hydrostatic pressure, the oncotic osmotic pressure of the Bowman's capsule, and then the colloid osmotic pressure of the glomerulus. So a couple arrows I have here. If you see the blue arrow, that's the glomerular arrow. So that all that force, whatever, either it's hydrostatic pressure, which is just basically high blood pressure pushing one direction. That's coming from the ball of capillaries. And then the green is coming from Bowman's capsule. So the basic concept I have here is if you look at the top, there's two forces getting blood into the glomerulus, or the nephron tubule, which is going towards the proximal convoluted tubule. So it's teamwork of both the glomerulus and Bowman's capsule. So the first part, you're going to see blue, that's the hydrostatic pressure, or the high glomerular pressure, pushing blood out from the arterial end side into the glomerulus. Then you have another pressure also aiding that, which is Bowman's capsule's high oncotic pressure, or high osmotic pressure. All that means is that there's a bunch of salt there inside of Bowman's capsule at the arterial side, and that's going to suck up the fluid getting pushed out by the high pressure from the glomerulus. All right, so from the high arterial end, it's pushing out high pressure, and then Bowman's capsule sucks it in. But it doesn't push it all in. And since it's like a capsule, you're going to have pressure, a back pressure coming back and pushing it in. So you're going to see in the green arrow, that's going to be high Bowman's capsular, Bowman's capsule, high hydrostatic pressure pushing it outward, because it's like a kind of like a little it's a ball, so it's pushing the it in, and it's getting a bottlenecked effect, but only so much goes in, and then it starts pushing it back out. Then you're going to also be aided by high colloid osmotic pressure in the arterial side. So then that's going to suck it back in. So if you look here, you're having high pressure on one side, push it out into the tubule, and then you're having high osmotic pressure inside the tubule, suck it in, and then on the efferent arterial side, which could be compared to the venule side of the capillary bed, that part has a high glomerular pressure pushing out, and then a high efferent arterial side or glomerular colloid osmotic pressure sucking it back in, which then takes it to the efferent arterial. So if you look here, just these two arrows, high pressure. If you follow the arterial, the efferent arterial, it's going to come all the way up to the glomerulus. It's going to start pushing pressure out from that blue arrow, and then Bowman's capsule's high osmotic pressure is going to suck it in. But not all of it gets there, and it starts getting turbulent, and that's where you see that U turn around, and high Bowman's capsule pressure starts pushing it out, and then the high glomerular colloid osmotic pressure sucks it in. The colloid osmotic pressure is due to high positive charge proteins inside the blood that's going to suck it in. So those albumins have a high charge. Those can't get through. They're too big. So then they go pull it back in, which then pulls it back towards the efferent arterial. So then once it gets to the efferent arterial, that is when that's when the blood, it then goes to the peritubule capillaries. So peritubule capillaries, peri meaning around, tubule meaning tube, so they surround the tubule. All those do is that those are right next to the nephron. The whole nephron loop in the renal cortex portion of the capillaries. So peritubule capillaries, peri meaning around, tubule meaning tube, so they surround the tubule. All those do is that those are right next to the nephron. The whole nephron loop in the renal cortex portion of the nephron. Those the peritubule capillaries allow for absorption or reabsorption and secretion of the minerals to control blood pressure or get toxins out or stuff that you don't need in there to make urea. But for our things, we're thinking about how are we going to regulate blood pressure, and that's the swapping back and forth of minerals between the peritubule capillaries and the nephron tubule, which is the proximal convoluted tubule and distal convoluted tubule on the collecting duct. And that's all for this video. Hope this makes sense. If you guys have any questions, just leave a comment. All for now. All right, guys, that's it for now. See you later.